Hello everyone, welcome you all again in my YouTube channel. In the second part of the video of the chapter Carbon and its compound, there I discussed with you about the saturated, unsaturated hydrocarbon. What are the hydrocarbons? What is the meaning of saturation, unsaturations, as well as the functional group. We have made a chart of hydrocarbon. There I said open chain, then closed chain. After that, from the open chain, that means aliphatic hydrocarbons. From there we get saturated, unsaturated hydrocarbons. From the closed chain, from there we get the two parts, alicyclic and aromatic. So from alicyclic we get cyclohexane, or means cycloalkane, cycloalkene, cycloalkyne. And from aromatic we get the example of benzene. So this chart we have done in the last part, as well as I have said something about the homologous functional group. So I just touched the topic, but here in the third part I will discuss with you some differences. The first thing I will discuss, what are the differences between radical and functional group. After that, homologous and isomerism, what are the basic differences between them. And then the very important thing from the organic chemistry, that is alicyclic and aromatic, this difference. Okay, so total three differences I will discuss. So the first thing I'm starting with the point functional group and radical. So I'm coming at the first to the radical point. What are the radicals? Radical means, suppose at the first I'm giving you the example, NH4 plus, that is ammonium, NO3 minus, nitrate, carbonate, CO3 2 minus, hydroxide, OH minus. So cyanide, Cn minus. What are they? So here different atoms combine with each other due to their unpaired electrons, or you can say due to their uneven charges. So they combine with each other and behaves like one single atom. If I say sodium nitrate, so what will be the chemical formula? NaNO3. If I say sodium sulfate, so Na2SO4. So SO4, NO3, CO3, these all are the functional group. These are the radicals, because they are exchanging the cations and anions and behaves like one single atom. But functional group, what is that? In organic chemistry specifically, we see the functional group like OH. So you can say ki ma'am, in radical also you say OH. Yeah, OH is common in functional group and in radical also, but in the radical we say OH minus. So there we say the charge of it. But when the same thing ki OH I am taking in functional group, in the case of organic chemistry, there I will tell this is all, or methanol, ethanol. So wherever we get OH, there as a suffix we will write all. Okay, so hydroxyl group, this is hydroxyl group. Then C double bond O, that means it is ketone. If I say COOH, COOH means carboxylic group. Okay, so what are the functional group? What is the definition of it? So you can say functional group means when more than one atoms will combine with each other and it will present in a specific organic compound to give it a new property, that is to be called functional group. Suppose if I say methane, methane means CH4. methane is a saturated hydrocarbon. When OH means hydroxyl group will sit with methane, it will be CH3OH. Then this is methanol. It is a form of alcohol. CH3COOH, carboxylic acid. So functional group will replace the hydrogen atom, one hydrogen atom from hydrocarbons, because methane was CH4. But when I write CH3OH, it will be methanol. So functional groups replace one hydrogen atom from saturated hydrocarbon and then it will occupy the place. So here functional groups are not exchanging their charges. They share their pair of electrons and after that they form functional group to give the specific chemical properties to a organic compound. Okay? Acha. Next difference I will tell, that is isomerism and homologous. So at the first I am starting with isomerism. Isomerism means if you write the same chemical formula of hydrocarbon, but when you are making the structure, then you find the position of carbons can change their places. In that case, you must say this is the structural isomerism. So formula is same, but structure of carbons are different. They are differently arranged. It is isomerism or structural isomerism. Now I am coming to the point of homologous. Homologous means, suppose I am giving the example like methanol, ethanol, propanol, butanol. So here the same functional group is sitting with different hydrocarbon, where the hydrocarbon differs with CH2 and CH2. That means if you see CH3OH, that is methanol, and then C2H5OH, that is to be called ethanol. So methanol to ethanol, differences of carbon and hydrogen will be CH2. Now come to propanol. Here also you find, means from ethanol to propanol, here also you find the differences of carbon and hydrogen, that is CH2. Okay, so here the functional groups are sitting, that is same to same, functional group is OH, but when functional group is coming to a different saturated hydrocarbon like methane, ethane, propane, butane, then it is to be called homologous. Homo means same. Which are the same thing here? Functional groups. Where it is sitting? It is sitting with hydrocarbons. And what will be their differences? Now hydrocarbons will differ with each other by CH2. It will differ by CH2. So methanol, ethanol, propanol, butanol, these all are the examples of homologous. Okay, why homologous? I think now you have understood it, because all are coming from the same category. Methane, propane, butane, all, pentane, hexane, all are from alkane groups. They all are coming from alkane groups. And after that, the functional groups are sitting with them and it will form homologous. Okay? Acha. Next difference is alicyclic and aromatic. So aromatic hydrocarbon, alicyclic hydrocarbon, these differences are very important, and don't be confused regarding aliphatic, alicyclic. Aliphatic means that is open chained. There is not a closed chain. Fine. And alicyclic. Alicyclic means both cyclic and aliphatic. Both the things are present. If I say cycloalkane, so cyclo means cyclic structure is present as well as alkane. Alkane means it is coming from aliphatic group, right? So aliphatic plus cyclic, both are present in alicyclic group, and in aromatic group only we can get cyclic or ring structure. Fine. Acha. Next, in alicyclic group you cannot get any fragrance or any specific odor, but when you check aromatic compounds, their fragrance or odor you can get. Okay. Acha. Next point, we can say that alicyclic can be saturated, unsaturated, both. Why I am telling ki both? Because you know alicyclic means cyclic plus aliphatic. So aliphatic may be saturated, unsaturated, both. Alkane, there are alkanes as well as alkene, alkyne. So alkene and alkyne, they are unsaturated. So saturated, unsaturated, both the hydrocarbons are possible in the case of alicyclic. But in the case of aromatic, that will be essentially saturated. There is no question of unsaturation in the case of aromatic. Only saturated hydrocarbon we get from aromatic. Okay. Acha. So these are the differences that we have discussed regarding alicyclic and aromatic. And I think now the differences between functional group, radical, this is clear, as well as isomerism and homologous, this difference is also clear. So in the third video, mainly I have discussed with you the differences of 3 points. Okay, and after that you will get the fourth part of the same chapter. So today this is sufficient. Bye everyone.